Okay, today you are doing constant rate of change. Our objective, I will be able to represent constant rates of change in mathematical and real-world problems. Rate of change is a rate that describes how one quality changes to another. If the constant rate of change between any two quantities is the same, they have a constant rate of change. So here are your three graphs you can have. Constant rate of change, you have the straight line. The second one, the rate of change is not constant. If you look, it kind of peaks up and then it goes to the right. Okay, and then the last one, no rate of change, obviously meaning go straight, nothing changes. Okay, our first example, what is the constant rate of change between the quantities in the table? Okay, so here is one way that you'll see it. So your first step is to find the pattern of the change. So your y is your dependent variable. And then step 2, find the pattern of change in your independent variable, which is your x values. Okay, it makes it independent because it doesn't change, and whatever the y depends on, the y is the one that changes. So, and then your formula for rate of change is your change in y divided by your change in x. Okay, so here are dogs is my independent variable, because you can't, it depends on how many dogs you have, it will depend on how many legs you would have. Okay, so then your y are the legs. Okay, so first we're going to find our change in y and our change in x. So here I set to subtract, so how do I get from 18 to 20? It's by 12. I get from 2 to 5 by adding 3. Okay, so my rate of change is my change in y, which is 12. Okay, so you'll see it written like this, change in y over change in x. So my change in y is 12, my change in x is 3. So my constant rate of change is 4. Okay, example 2, we're going to use a table to find the constant rate of change. So we're going to look at the graph and create our table. Okay, so we know that the horizontal is our y, or x, and our vertical is our y. Okay, so what I'm looking at are each of these points. Okay, so we know our first point is at 0, 0, because it crosses through the origin. Okay, our next point here is 2, 80. Then our next one is 4, 160. And then our last one we have is 6, 240. Okay, you also can tell it's a rate of change because it has that straight linear line. So now I'm going to find my change in x and change in y. So looks like here I'm adding 2 every time. Okay, here I'm adding 80 every time. Okay, so to find our constant rate of change, our rate of change, which is our k, is our change in y over our change in x. So our change in y is 80, our change in x is 2. Okay, so 80 divided by 2, we get 40. So our k, our rate of change is 40. Okay, example 3, we have a computer program charges customers per line of code written. Find the constant rate of change. Okay, so same principle. This is my x values, this is my y values. Okay, because it depends on however many lines I write will depend on the cost that it's going to cost me. So my change here, I go from 50 to 100, I'm adding 50. 100 to 150. So our pattern here is adding 50. So our change in y, we're adding 1,000. Okay, so we're gonna go put it into our formula. So we have k equals our change in our y over change in x. Okay, so our change in y was 1,000. Our change in x is 50. So our k, or our rate of change, we make it our number smaller, so 100 divided by 5, we get 20. So here our rate of change is 20. Okay, last but not least is your you try. You can just put it somewhere on the notes page that I gave you. Don't worry about, since you're going to be gluing it into your journal anyways. So you have Daisy can read a certain amount of words per minute. What is the constant rate of change?